In this video, I'm going to take a look at the relationship between the unit circle and special right triangles. So a unit circle is just a circle with a radius of 1, and it's centered at the origin at 0, 0. And so a lot of teachers will have their students memorize all the x and y coordinates on the unit circle, and it's actually not as bad as you might first think because there's a lot of symmetry here, right? The x coordinate here is going to be the same as the x coordinate here, only this one will be negative, this x coordinate will be positive. This y value is the same as this y value, so that's the same. And that really goes all the way around the circle, so compare this one to this one. You see that this y value and this y value are the same distance. One just happens to be positive and one's negative. The x value of this point is the same here as it is here. It's whatever this distance is. Now, I tend to use special right triangles to think about this. And in this video, I wanted to show you why you can do either one. Okay? And so to do that, I'm going to just think about cosine of 7 pi over 6. Actually, I think that'll be 5 pi over 6 here. Yeah, 5 pi over 6. So let me get rid of the extra stuff on this unit circle. So I just want to look at just the circle here. And like I said, this is going to be 5 pi over 6. Not 7 pi over 6. I wrote it again. Okay, so 5 pi over 6 is just under 6 pi over 6, which is pi. And so this angle here is going to be 5 pi over 6. It has a reference angle of 30 degrees. And so we then can look at this right triangle here. And so we can, don't want to do that. Okay, well, I'll just leave that there. So the issue with this is, it's not really an issue, it's just we know a 30, 60, 90 triangle has a ratio of 1 to square root of 3. And if I was to find the cosine, actually let me not get into that quite yet. So I've got 1, 2 square root of 3. The problem is this triangle here has a radius of 1, or hypotenuse of 1, instead of here we have 2. So that means we have to adjust the other side length. So how do we do that? Let's actually draw this more, at least closer to scale. So instead of my radius being 1 here, like this, what happens if I take and make this 2? Okay, so I'm just gonna eyeball it. So I would say about, is that about twice as long? Roughly, I would say that's twice as long. So this green segment is actually 2. And so when I draw this in, this is 1, and this is square root of 3. Okay? But then we've got this purple triangle here that is similar to the green triangle, the same shape, just smaller, and its hypotenuse, or the radius of the circle, is just 1. So the way to kind of think this through is to recognize from 2 to 1, that's half as big. And so if I just divide 2 by 2, that's going to give me 1. So to get from this side to this side, it's going to have to be half as big as well. You could also use a proportion or ratio as well here. But if I take 1 and I divide 1 by 2, that's going to give me 1/2. And if I take the square root of 3 and I divide that by 2, that's going to give me the square root of 3 over 2. And so you can see here, we can find the ratios for the small triangle based on the ratios of the large triangle. Now, back to cosine of 5 pi over 6. If I want to find the cosine of 5 pi over 6, I can use this small purple triangle. If I do, I take x over r, because that's the definition for cosine. But since the radius is 1, then x divided by 1 is just x. So really, the advantage of using a unit circle is that we don't have to worry about the radius. We just have to find the x value. So what is the x value here? Well, if we look at the purple triangle, this point here, the x value is going to be negative square root of 3 over 2. The y value is 1. Why is it negative square root of 3 over 2? Well, it's to the left. Any x coordinate to the left of the y-axis is going to be negative, right? So if I want to show that in my picture, I could just put a negative sign here. Now the y value is positive because it's above the x-axis, so it's positive y values. So back to cosine of 5 pi over 6, it's just the x value if the radius is 1. So the ratio is negative square root of 3 over 2. Okay? Now, if you do it using the green triangle, it's not a unit circle, but the definition of cosine is still x over r. My x value here is going to be negative square root of 3. Oops. And y is positive 1, square root of 3. But now my radius is 2. You'll notice the answers are the same regardless of which method I use. And so here we get negative square root of 3 over 2 regardless. One advantage of working with the big triangle over the small triangle is you get to build on your geometry. I suppose this is really geometry as well. But let's look at tangent of 5 pi over 6. I'm going to pick a different color. Go use dark purple. Consider tangent of 5 pi over 6. Using the unit circle, actually, the definition of tangent is y over x, regardless of what you use. But if you use the unit circle, which I'm going to show by using the purple, your y value is 1. Your x value is negative square root of 3 over 2. And then you need to simplify that to get negative 2 over square root of 3. If you use the green triangle there, your definition is still y over x. But with the green triangle, the big triangle, you can see y is 1. X is negative square root of 3 here. So you get 1 over negative square root of 3. And we've got an issue, right? Those things should be the same. I see my problem. Do you? My y value isn't 1. My y value is 1/2. So on the unit circle here, I copied this down incorrectly. Ooh, didn't want to do that. It should really be 1/2. That's coming from my y value here. Sorry, there's a lot going on here. And so then, when you reduce this, I don't know. Sorry, I covered that up and it seemed like a good idea at the moment, but here's what I'll do. I'll do white on top of this. All right, so to reduce this, there's a couple ways of going about it. I don't know what's going to resonate with you the best. I multiply by the reciprocal myself. So for me, I would take 1/2 times the reciprocal of the denominator. So that's 2 over negative square root of 3. The 2's are going to cancel and I get 1 over the negative square root of 3. So this is equal to 1 over negative square root of 3. Okay, so let me run through that one more time since I messed that up. So I'll just start from kind of the beginning. So working with cosine of 5 pi over 6, we get a radius of 1. If we want to use a radius of 1, then we have to adjust our ratio, not really our ratio, but we have to think about the ratio of this triangle, 1, 2, square root of 3. This is 2 because it's twice as big as this one. And to get to the radius, we divide by 2. So that's divide by 2. So we have to divide all our sides by 2. And that gives us this new point here. Not new point. It gives us the coordinates of this point on the unit circle. And so when I find tangent, I have to do y over x, which is 1/2 over the negative square root of 3 over 2, which reduces to 1 over negative square root of 3. If I use this big triangle, the ratio is going to end up being the same. I'm just not using a unit circle, so I have to use y over x. My y value here was 1. My x value, since this is to the left, is negative square root of 3, so I get 1 over the negative square root of 3. So some of you will want to, sorry for the alarm, some teachers would prefer this to be rationalized, and if you rationalize it, you would get the negative square root of 3 over 3. So I would accept either answer there, either form. So hopefully you found this helpful and helps you understand why it's okay to use either a bigger triangle where the radius is 2 for my circle. I didn't really draw that in, but if I think of this as a big circle, that's where that's coming from. Or if you want, you can use a radius of 1 and use these coordinates.